Here is like a more recent, more exciting use of these systematics. Thanks to the high resolution capability of the ICPs, people start to analyze neodymium in bone and tooth enamel. Traditionally, strontium is the element for these type of studies, but now they are adding neodymium. So here they took samples from different parts of the world, like in Europe, South America, Caribbean, Iceland. They plotted these samples using the neodymium isotopes versus strontium. The solid boxes is the traditional region or characteristics for the samples, the bone samples coming from different places. So if you have a sample from South America, technically it should fall within this box. And the dashed line refers to the strontium overprint of the sea spray. So if you have your sample collected from the region by the sea, you should expect to get some sea spray strontium effect. And this is why if your sample is affected by sea spray, it should fall within this extended box. But this is like a very cool example of how you can utilize neodymium along with strontium for your human mobility study. You can use that in any kind of bone. Here is another study done on the animals. So here you see the strontium ratios of bone versus the strontium ratios of rocks and minerals, and this is 1:1. And as you can see, these are the range of the samples, right? For water and rock samples, the range is so wide. But in general, in some of the animals, you see they are really close to 1:1. So technically, they are reflecting the composition of the water or geological formations. And here is the neodymium, epsilon neodymium of bone versus the epsilon neodymium of rocks and water. And as you can see, here is your 1:1 line. And most of these samples are plotted close to 1:1. Now, the cool part is when you plot your epsilon neodymium versus strontium, this is what you get. As you can see, different animals from different parts of the world, their strontium values are falling within a relatively narrow range. Yes, you can zoom in and differentiate between these animals based on strontium ratios, but sometimes you can't. In case of these two examples from the whale from Germany and Netherlands, you see the strontium isotope composition is very close to each other. So by adding the neodymium to the equation, you see the neodymium values are wider, the range are wider. And this is like a good example of why we use multiple isotopes in our studies.